Quick little background on me. My name's Nate Taggart. I am a founder at Stackery. We're based in the US. We've been doing serverless development for over 3 years now. I've talked to about 200 enterprise serverless teams at this point, seeing the patterns that they're using and what's working. Also one of the organizers for the Portland serverless meetup. We are one of the largest serverless meetup groups in the world. We have over 400 members, so lots of like real world kind of hands-on anecdotal data coming into this talk. And we ran one of the Global Serverless Days event in Portland as well. Prior to Stackery, my background is actually coming out of New Relic. I was an early employee there, second product manager, stayed till the IPO. And a nice little run, and spent a lot of time thinking about software quality, software performance, software reliability. And after leaving GitHub, New Relic, I went to GitHub where I ran the data science team, which isn't super relevant. So when we talk about this new way of doing serverless testing, I keep having people come to me and ask me like, you know, kind of good, but maybe basic questions about how do they get started with testing in the serverless world. And I've collected this anecdotal experience that I think everybody goes through, which is you start out and you build your first serverless function. It's the hello world version, and you get it out the door, and you're like, this is fucking great. It's going to work super well. Tests are probably pretty straightforward. You're already, you know, thinking about how do I break this application down into these small little functional components. Makes unit testing straightforward, if nothing else. And then you get into integration testing. And if you've done some Googling, you probably have run into this scenario where like to do integration testing, you're trying to figure out how to get like a Docker cluster running so that you can mock up all these services. And as you go through this progression of trying to create kind of battle-hardened tests, eventually you stop learning how to test, and you start learning how to convince your boss you don't need to test, which seems to be the easier path through. And the thing here is that serverless testing isn't actually hard. Serverless testing can sometimes seem hard, and the reason it seems hard is because we're bringing these expectations to serverless from some other development patterns, and they don't all fit. So first reason that serverless testing seems hard is that serverless involves a lot of managed services. We have a tendency to point and focus on the function as a service element of serverless. Serverless, though, the serverless pattern typically involves using third-party SaaS providers, using managed databases or other managed pieces of infrastructure. And you can't replicate all of the cloud on your laptop. It's an uphill battle to try to replicate every single managed service locally in order to test it. We need to shift this and potentially think about testing in the real world environment of the cloud. The second reason that serverless testing seems really hard is because now we are all professional YAML engineers. Every time I want to stand up a new instance of this application that I'm working on, I have to write a new configuration template for that, or modify the existing one. If I want to, sandbox a new integration test environment, it's not enough that I have my infrastructure as code that works for production or maybe works in my development case. I now have to also create it for an integration test. And as I create a change, I have to propagate that change out through all my templates, and this becomes kind of a nightmare. So, and then the final reason I want to call out on why serverless testing seems hard is because, frankly, the development model has changed. Yes, we can write code on our laptops, of course, but our laptops don't replicate the runtime environment as well as they have historically. I can set up my laptop to be a perfect replication of an application server. I cannot set it up to be a perfect replication of a cloud provider. And so shipping our software to the cloud becomes part of the software development process. It's no longer just a late-stage ops responsibility. And as this shifts the way we're building and writing software, it also impacts the way that we're writing tests. So we're going to start from scratch. We're going to talk about some basics, some things you're very familiar with, and that's okay. And then we're going to build until we have a complete solution for how should we be thinking about testing serverless applications. I also got to say, I love the turnout here because these are the people who are taking serverless seriously. You deserve a round of applause for yourselves. So let's start here with unit testing. Good news, it's easy to do unit testing. Purpose of unit testing, of course, is to test our code, test each of the paths through our code, and make sure that it behaves the way that we anticipate. Typically, we're going to do this by running in kind of all the test case scenarios, the edge cases. You can continue to almost certainly use whatever test framework you've been using. It'll still work. You can run it locally, and it's pretty straightforward. I do want to call out, though, that there's one little difference here. As an industry, we have had a problem lately of overloading this word function. We talk about Lambda functions, or functions as a service, or cloud functions. And these are not synonymous with the code blocks that we have in our code that we define as functions. When we run an application on a cloud provider, say AWS Lambda, we can, in fact, put as many lines of code in that Lambda as we want, give or take. You can have multiple routes in that Lambda. You can do some of your routing logic within that Lambda and send it to different functions within that Lambda. So keep in mind when we're talking about unit testing and we're talking about breaking down to core functionality, that does not mean that each Lambda is going to have one set of unit tests for it. And now we get to advance a little bit and get a little bit more mature. And here's where the patterns are really going to, I think, shift from what we're used to. So the next type of testing that we're probably thinking about is integration testing. And I want to kind of define this a little bit more. It's in the name. We're testing the integrations. But we're really going to be testing the relationships between the different resources that we're using. And again, here's one of the ways that serverless starts to get a little bit more complex from what we're used to. Because if you were used to running a single monolithic application in a container and it connects to a database, there is one relationship between application server and database. If you've decomposed that application into 24 functions, there are now dozens, maybe even hundreds of relationships that you're going to want to test. There's an explosion of proliferation here. There are a few ways we can test this. So first off, we can test it in the cloud. We can deploy this. We can trigger events using the SDK. We can also test locally by standing up fake instances. This is where we run all of our Docker containers with a replicated environment. Or we could use mocks. We can script out the responses that we expect. We'll actually step through each of these. I have an opinion on the right way to do it, but we'll talk through how to do it. But do keep in mind that the number of integration tests is going to grow. Integration tests probably become the most important tests that you're running during this cycle. I also want to call out, as we started talking earlier, where we have this environment. If I want to deploy this to the cloud and stand up an integration test environment, I'm going to have to manage the deltas between my dev instance and my integration test instance. Even if that's just things like IAM roles and namespacing my functions and stuff like that, we're probably going to want to get more sophisticated about that. So let's talk about the first way to do integration testing, and this is using mocks. So a mock, again, is going to be kind of a hard-coded response. So we're going to make sure that if we get the response back that we expect, everything looks good. So the benefit here is it's very fast. You can run through a series of integration tests very, very quickly when you're testing them against some hard-coded value. The downside here is they're not very high fidelity. They're actually relatively low fidelity tests. In a way, they're a one-way test. You're testing against the expected anticipated behavior. You're not testing against real behavior. So what you're doing here is you're testing your assumptions, which is perfectly reasonable if you're good at making assumptions. There are some pretty high quality mock libraries, and certainly these are a tool you should have in the tool chest. I'll talk about the one that I like. But one thing to keep in mind is that there is a delta between the real world and these libraries, even between the good ones. They will not have every single AWS service replicated, or any other cloud provider, for what it's worth. But they will also not necessarily behave identically either, right? They may have some nuance in how they work and what you would expect in the cloud. So pick a good mock library. You're going to want to kind of maintain some local collection of these events that you want to test with. So here's an example. Here's a test library. I'm going to see if I can stretch this out a little bit, because it's, well, maybe not. OK, so with a test library like this, what you're basically going to do is, so here's one I like. It's called Modo. Modo is a little bit of a play on words against Bodo, which is the AWS SDK. So Modo is a Python library that works synonymously with the Bodo AWS SDK, except instead of actually making real calls, it's going to replicate the expected response back. So you're going to be able to work with it very similarly. It's going to have the same kind of syntax you might be used to with the SDK. And I will call it that I actually like this library. It's high quality. It has a bunch of services, probably like 30 or 40 different services that it supports. Still does not have every service that you may want to use. Which means that if this doesn't cut it for you, you might want to stop relying entirely on mocks and start using fakes. So fakes is going to be some kind of local replication of the behavior of a cloud service. So you can have a fake for Lambda. You can have a fake for Kinesis. You can start to test the integrations between these services. And you are, in fact, running kind of a replicated version of the service locally. So you can, again, integrate these fakes with the SDKs. So here in the case of AWS, we can actually define where we're going to run our fake local Lambda instance. We can define kind of a local address for that. Using AWS SAM, we can then start a local instance of Lambda running on our laptop that should replicate as closely as possible real runtime, real behavior, real system limits. We can then integrate all of these replicated services together and test the connections locally. Again, higher fidelity here, because now we can actually test behaviors coming from both directions. We can say, if a Lambda gets this event, what does it do? We can also say if a Lambda calls out to that database, what response does it expect back? So we've gone past testing assumptions. The problem is now, to do serverless development, you're managing a bunch of Docker images, which maybe wasn't the goal when you started on the serverless path. Still works, and it can be kind of high velocity once you get this test infrastructure set up. You then, of course, have to train all the other engineers on your staff how to get the test infrastructure set up. So now you're a YAML engineer and a teacher. And this is where I think we really should probably be thinking about heading as an industry, and that is that we are building cloud-native applications. We are now deploying, as software engineers, we're deploying directly into the cloud. We're using self-service infrastructure. And that model needs to go all the way through the development lifecycle. When we're thinking about testing, we should be testing in the cloud. And when we're building, we should be building in the cloud. I'm going to tell you the truth. It took me a long time to come to this conclusion. I was talking with some of the product leaders behind AWS Lambda. And I was asking them, like, why it wasn't easier to do things locally. And they told me, because I shouldn't do it locally. I should do it in the cloud. And I thought that was just their like marketing spin. You know, like, of course you want me doing everything in your cloud. That will cost me money. But the reality is, it's true. It's higher velocity. Every single engineer on a team can stand up a test instance. And it's basically free. You're not running high volumes of traffic through these services. So there's no reason to now like meter infrastructure in the way we have in the past. If everybody on your team needs to spin up like a whole orchestration platform in order to test the infrastructure, that gets expensive very quickly. But on Lambda, it's practically free. So I'm a proponent of integration testing in the cloud. So the case here, it's going to be very, very high fidelity. It's going to test actual things like, are the permissions configured correctly? And if serverless is the first time you've had to configure IAM rules for yourself, you probably want to test some of that. It can be a little bit slower because testing now involves deploying. Deploying can take a little while. If you're using something like CloudFormation, you may have had previous experiences where that took a long-ass time. It's getting a little bit faster, like slowly and surely, but it's been getting faster. So it might be time to take a fresh look at that. I do think, though, that to do this well, we do have to dig into environment management. So we'll talk about some ways to think about that. But ultimately, you'll want to grab the SDK. I'm using the AWS SDK, which is Bodo. or grab something else off the shelf that's appropriate for your situation. And then we can start doing real integration testing. So these are integration tests in a production-like cloud environment. We may be isolating it or sandboxing it from the rest of our instances. And we can, again, use that local SDK to invoke a resource in the cloud. So, for example, let's say I have an API that's fronting a Lambda instance that connects to a database. I can use the SDK to just call that Lambda, inject in the event to trigger it, and make sure that I get the right response back, right? In this case, it should be normally responding back to the API, so I want to test that I'm returning an HTTP 200 status code and that I'm pulling the right record out of the database. And this is where it gets tricky if we don't have environment management, so I really want to hammer this one home. So here's what serverless development looks like today. I write my application, and then I write this template, this YAML file that describes my architecture. And it's not just enough to describe the resources I'm using, like I'm using this Lambda. Maybe I'm putting it inside of a VPC. I'm connected to this database. I'm also mapping the relationships between each of them. And I'm hopefully securing it by sandboxing this application with IAM roles that are scoped, that are limiting access from this resource to only talk to the resources it's allowed to. Which means that this is an environment-specific configuration, even if I'm not thinking of it that way. If I only have my one instance, let's call it development, I've got this one template. When I promote that to production, I now have all these kind of dynamic attributes in the template. If I'm running in the same AWS account or the same cloud account, I now have the namespace, those different functions, so they're not colliding with each other. I now have updated IAM permission roles where I'm isolating things, I'm sandboxing things. I have different resources that I'm pointing to. And I can do this. I can probably handle these two environments, and I can pull them up side by side and just kind of go through line by line, make sure they line up. And then I add integration testing. And here's a third one that I'm going to manage. And that's OK. I can kind of do this too, although this is starting to take an awful lot of time. And since it's taken me so long, my boss offers to put someone else on this project. So now I have more people that I have to coordinate this with. Every time I make a change, I not only have to propagate it through every lifecycle stage of this application, but I also have to propagate it through every other developer. And that's fine, because I'm really good at telling people what to do, but it really sucks when then they all have to come tell me how to change my configs to match theirs. This becomes a people problem. It's no longer a technology problem. If you are not putting some solution around this, you are going to struggle taking serverless very far. This problem is hard with one person. It is nearly impossible with 2 to 5 people. After that, it is impossible. This doesn't work over 500 people. It just doesn't. It doesn't scale that well. I came out of GitHub, and I don't know the Git foo to make this happen well. It's just too hard. You're going to need an environment solution. And this is one of the building blocks of Stackery. You can do this yourself. If you're doing this yourself, here's what you need to be thinking about. You want a way to manage environments, list them out, to create a new one, to have a set of these are the environments we support. Each of those environments needs to have some kind of parameter store so that you can basically swap in, okay, when I deploy to testing, pull in these settings. That parameter store is not secrets management. Parameters and secrets are not interchangeable. We need to put secrets somewhere that are actually safe and secure. It's great if you're pulling your parameterization out of your template, out of GitHub. Good on you. Take secrets a step farther and put those in a true vault or secret manager. You're going to want to handle namespacing. You can do this with people rules. So you can say, we always name things this way, follow this pattern, and try to get everyone to do that. Or you can do this automatically with software that just is going to name these things dynamically. You're going to want to integrate your entire pipeline. Go from your version control system all the way out the door to your production cloud. Every step of that should be able to be automated and should be kind of aware what environment are we pushing into from what branch in version control. And you're going to want some CLI tooling to support all of this, because if you don't wrap this with tooling, it's not going to work anyway. You don't want this to be a manual process. So at the very basics, like what your CLI needs to be able to do is deploy from a branch to an environment stage. Should be kind of aware of the cloud account structure that you have to do that. You're going to want to be able to undeploy. This is key. After you spin up your integration test environment and run your test, shut it back down. And you're going to want to be able to describe that thing that you just deployed. You stand something up, you're going to want to get back resource numbers, API endpoints, all of these attributes that you just created. You want to query them so that you can script against them to then automate through your testing. I think that's the minimum. If you do that, you've probably got a good enough system. You're going to be ready to do real automated testing, full lifecycle management. If you want to take it a step further, some things that I think are really meaningful improvements are to have IAM rules actually be programmatically created and scoped. This is a touchy one. Not everyone wants that. But I will say trying to teach 500 people to never screw up an IAM rule is probably not the right approach. And writing software to do it might be better, and that's my view. So if you could bake that into this environment management system, so you say, hey, when I have these two resources and I'm designing them to connect to each other, let them connect, but don't let anything else get in the way. Parameter management, this is one that we've kind of learned as we've gone down the path is it's great if you've parameterized your template. You then need some patterns so other people know, like, these are the parameters I need to define in order to deploy this application into my own development instance. Maybe some access management. Which ones can I see? Can I see how you set yours up, or can I not see how you set yours up? Those kinds of things matter. All right, we talked a lot about environments, and we did that because environment management is pretty important if you want to do integration testing in the cloud. It is flat out essential if you want to do system testing in the cloud. Integration testing, we have some other options. We can do mocks, we can do fakes. With system testing really is about recreating the production environment and actually hitting it and making sure it's working correctly. I like to think about integration testing as we're behind the scenes. We know how it's supposed to work, and we can test those components. System testing can be done from the outside. We're going to send our tests through the front door of the application to do a real transaction and make sure we get the expected behavior that we would anticipate. So we're going to rely on all the public interfaces. So if you're building an API, that means we're triggering tests through API calls. If you're building a web application, could be that you're triggering them through the API calls that support that web application. It could even be scripting against your real application. The good news here is system testing in the serverless world is now something that everybody can and should be doing because it's affordable. It was not always affordable to give every single developer a complete production replication. It's actually pretty trivial to do that in the serverless world. Again, we're only paying for what we're actually consuming. But we're only going to be able to do this if we can create environments. Because if we do this the right way, every developer is going to have a developer instance of the application. And then they're also going to have a developer integration test or system test instance of the application. So we're going to end up with a lot of instances, and we want to be able to manage that. So let's talk about system testing. So the good news is they're relatively straightforward. This is kind of a trivial example. But in the case of that last integration test we ran, we had an API endpoint. It was connected to a function. It relied on a database. We kicked it off by sending that function an event to trigger it. In this case, we're going to kick it off by actually sending the API request to the front end. Now, I've made this trivial. I haven't handled things like authentication or anything. Good libraries are going to support that. You can layer it in. This is the easy part, by the way. This is the software. We all know how to write this. The hard part is really thinking about kind of how do we scale this across our team and across our organization or across our project. So what I've found is kind of the best way to do this is to think about it in terms of actual use cases, like business transactions. I'm not concerned here about test coverage in the sense that every route of code is hit. I'm concerned about this in terms of, am I going to get fired or not? From, do the critical paths through my application, are they working correctly in a production-like environment? So if I have an e-commerce site, I want to make sure I can check out. I also want to make sure I can sign up for the newsletter. I want to make sure I can do the meaningful things for this application. And I want to make sure I can do them going, again, through the front door, just like a customer would be. There's another kind of similar type of system testing that you may be familiar with. So I wasn't involved in this product at New Relic, but New Relic has a product called Synthetics. It's one of a dozen synthetic monitoring products where you can just use typically like JavaScript to script out a transaction. Again, probably against like the UI of the website. But one kind of cool thing about serverless is that we don't have to use products for these kind of boilerplate use cases. Serverless Chrome is an example of running kind of a headless Chrome on Lambda. So you can actually script out your business transaction and set Lambda up to run once an hour. You can do 24 hours a day, make sure that every hour the checkout system gets tested with a real transaction. You could also then have that Lambda trigger another Lambda to go clean up that transaction. It's in your system. You can actually, like cancel that order or whatever it is you need to do to not send a bunch of spam to your ops team. So I put another like GitHub reference here. Serverless Chrome. It's maybe a kind of easier way to get transactional testing through the system. All right, so those were the three kind of big testing methodologies that I suspect everyone here was at least moderately familiar with. I was joking about testing in production, and now I'm not joking about testing in production. We're going to talk about testing in production. If you're not familiar, there's recently maybe been a new movement emerging called shift-right testing. It's a little bit tongue-in-cheek, but it's actually a good premise. And the premise is this. With every other kind of test that we're running, we're testing in theory, right? And I think there's like a famous quote, the difference between, in theory, there's no difference between practice and theory, and in practice there is. We've been testing against kind of this anticipated use. And then we have people come use our website, and we shouldn't just ignore that they are accidental testers of our software. If we can capture meaningful data from these real users, we can extrapolate out of that not only what are maybe the flaws in our code, but also what are the gaps in our tests, and then we can even prioritize them and say what are people really hitting the most and what do we need to worry about. So the trick with shift-right testing is that we're going to uncover the gaps that we didn't anticipate by instrumenting the application, observing real behavior. The big shift here in the serverless world, though, is that we are now in charge of ops. We haven't outsourced that to anyone. If I want data collection out of my application, I have to instrument it during development, because once that function invokes and dies off, it's gone forever. I can't go back and get anything meaningful out of it. So as software developers, we are now instrumenting code. We are now creating whatever level of observability we're ever going to have. There is basic logging, some basic metrics collection in every cloud provider. It's garbage. It's not enough, flat out. So I'm going to show you a couple tricks we're using to get some better data out of our applications, and they're actually pretty simple. So the first one is an instrumentation technique to pull out richer event diagnostic information. First thing, I'm going to go on like a little side tangent here. Events should never have confidential information in them. Events should be pointers where the Lambda or your resource can go fetch meaningful information. So we shouldn't worry about having event diagnostics if we're using events correctly. But events diagnostics allow us to then go replay transactions in our application, to actually recreate what was that error scenario. And the way that we're going to capture this event data is through a generic handler, a function wrapper. So basically, we're going to define this handler. This is my generic handler. Every single Lambda is going to have this generic handler entry point. And what the generic handler is going to do is take the context, pass it into the real handler, the function I actually want to run, and try it. And if it fails, I can catch that failure. I can extract the meaningful data that the cloud provider wasn't extracting for me, like my event diagnostics, log them out, do whatever I want, and then I can just throw the error. So I'm not changing the behavior of the application. I'm not doing anything goofy here. But I am catching the failure before the invocation dies off, and I can never get that data again. So this is, again, this is a lightweight, kind of trivial example. We'll do one that's a little bit more sophisticated here, and this is around timeouts. Hopefully, you're not having tons of functions timeout, but when they do, I bet you're scratching your head as to what's causing it. So one of the ways that we handle that, again, is with a kind of a generic handler. We're going to wrap this around our real function. In this kind of Python example, we're going to spin out a new thread, run the real function in it, set a timeout for ourselves on that function, and then if we hit that timeout threshold, my main thread can still do some diagnostics before I hit my cloud provider timeout. So in this case, I'm setting that thread to time out 1 second before my function will actually time out. I have 1 second of buffer to extract meaningful information out of that. So if we provide a little bit of extra observability into these serverless applications, now when they're running in production, when there's an error, when there's a problem, I actually have meaningful data I can use to react to that. I can recreate this transaction. But that's only meaningful if then I can actually map that back into my application, and in particular into my architecture. A lot of serverless is going to generally be a distributed system, and distributed systems tend to distribute their errors just like everything else. So you have a function that's causing problems. You may find that out when another function's failing to connect to the database or something. So if you give your team access to the logs, they're going to get all the information they need. The problem is they have to read all of the information to get it, and they're going to spend hours trying to search through, hunt it all down. One of the things that we found to be really useful is to then take that data and correlate it back to the architecture. Even if at a high level, you can say which services are having errors, that at least gives you a way to kind of drill in and focus and say, this service is creating bottlenecks upstream or downstream, and correlate the data, the raw information, back into kind of a meaningful collection, usable information that we can work with. When there's a crisis, I want to be able to look and say, it's this function freaking out, and not have to hunt through logs to try to map that. Another kind of late stage, real world production system test that we can run is to make sure that we're actually setting the policies and the access that we think we are. Particularly, I found one of the big pushbacks from the IT side of the house with serverless is not that they don't want developers to self-serve infrastructure. Usually that's great for them. It's that they don't think they'll do it right. They don't think they'll set things up well. I used to have a team of 10 people who managed all of production, and now I'm supposed to open up access to 500 people. That freaks me out. And so one of the ways that you can kind of help tick that box is to actually use Lambda, use serverless to actually help run system tests. And when I say system, I actually mean like your whole cloud provider. So Cloud Custodian is an open source project out of Capital One. With it, you can script up what are the rules that you expect to be enforced in your cloud. So for example, you can say, every S3 bucket must be encrypted. And then once you've set those rules, you actually can deploy this. It'll automatically manage the Lambdas and the events to trigger the Lambdas, to then set them on a timer to run through your cloud account and test these policies to make sure that they're being enforced. It can even do remediation behavior. So for example, it'll shut things down that don't conform to the standard that you've defined in your policies. So testing can extend into the real world. It can be used to build confidence, not just for yourself and your application, but also for the broader team, including people who are maybe skeptical of serverless usage in your organization. Just kind of recap here real quick. Unit testing is going to be the same. It's easy. Hope you can start there because it's familiar. Integration and system testing, these should be done in the cloud. We want to replicate as close to possible a production-like environment. And the tricky part there is not actually the testing, it's the environment management. You should be focused there. And then finally, shift-right testing. If we're having the software team self-serve infrastructure, we need the software team to be empowered with access to the data and visibility into the systems that they're supposed to be in charge of. With that, a quick plug for Stackery, my company. We do environment and configuration management among about a dozen other things. We act as an extension into your cloud console on top of AWS so that you can focus on building software and not YAML configuration. And with that, I thank you very much for having me.